Okay, so basically I just want to run through the plan of what we're going to do in this video for the SNAP project. And like I said, we're going to be trying doing this in baby steps here. Basically, what we're going to do is I'm going to show you where I'm going to get this data from. We're going to be visiting American Fact Finder. Second, we're going to load the data tables into this notebook and just go over some very basic information. Third, we're going to format the column headers of two data frames, and I'll explain why they're two in a minute. Then we're going to merge them using Panda's pd.merge function. I thought it would be a good idea to add some learning goals to the video, to the notebook, so you can see what I hope you'll learn from the video. And we're going to learn how to read a comma-separated value file and skip unwanted rows. We're going to understand what the shape of a data frame is. And then we're going to go over the basics of Panda's merge function and how to confirm it worked properly. And to do that, we'll be using the shape of the data frame. So it should all make sense by the time we're done with this. But first things first, I will have the folders included in the GitHub. Basically, what you'll be doing is downloading ACS 17 5-year B25031 and American Community Survey ACS 17 5-year DP03. These are economic characteristics, and we don't need all of the information that is going to be in here, and you'll see they are huge files. But we are going to need to get them off of the American Fact Finder so that we can have some semblance of uniformity. So what you're going to do is you're going to go to American Fact Finder and you're going to pull down the geographies, and what you want to do is we ultimately want to bring this down to the census tract number. So select census tract on that drop down. I'm going to be working in 5 separate states. I used a random number generator to decide which ones I'm going to use. I've already included those in the files I've downloaded, but they were South Carolina, Georgia, Kentucky, North Dakota, and Kansas. As I said, it was a random number generator. I used this little spreadsheet here, which I pulled off of this Wikipedia page, and just put in for 5 random numbers using the random library, and that was it. So basically, I went over to here, and see, South Carolina was the first one. So you'll hit all census tracts within South Carolina, add to your selections. Kansas, and it changes automatically. You'll do the same thing, add to your selections, and you'll add, the Kentucky, North Dakota, and the final state. Okay, so the next step is going to be to download find your topics. And as I said in an earlier video, this project is looking at some poverty data that includes poverty rates, the SNAP recipient numbers in a year, the earnings in each area, so we have an idea of what defines poverty in these specific areas. And then we have I wanted to put in the gross rent to give some idea of housing for rental, because if you're talking poverty, you're probably not talking home ownership, although fair to say you may be. That all depends. This is more of just to handle this data, to look at how we can work with it, and then you can expand from there. So I wouldn't treat anything as gospel at this point. But anyway, we go over to topics, and for poverty stuff, you'll go down to people and go down to poverty, and you can just hit food stamps, SNAP, it loads it. Then poverty will be the poverty rates, and then you can go up to income and earnings, and I did income/earnings household, and then that gets you to the one that we wanted. I went with the 2017 ACS 5-year estimate, just because it is it was the most up-to-date information that I had. Now it's only going to give you just like the 1 year or the 5-year estimate. Whenever you click on this, it'll take you to the download page, and you just hit this download button. It puts you together for you, and then you can go from there. But that's only one of the 2 data frames that we need. So we're gonna, after you downloaded that one, we're going to close out these 2. Going to go to topics and go to housing, financial characteristic, gross rent, and just download those. And like I said, I've already done them here. So the first thing that I'm going to do, let's read in or import pandas. Oh, import pandas as PD. And I don't know if I've mentioned this before, but the library is called pandas. I'm telling it to import and save pandas as PD. You can make it whatever you want, but pandas as PD is how I was taught to load it in. It's a pretty standard convention, naming convention for it. So if you were to get stuck on something and were to look up online, you're probably going to see pandas as PD, or they'll just do pandas. Anyway, let's go ahead and load that in. Okay, and I'm going to go ahead and load in my first table, and let's do T1, just the variable. I'll do it, table 1 equals pd.read CSV. And of course, we have it already in this directory, so I'm just going to start typing out ACS and hit tab, and that gives me an option for autofill. I'm going to do this one. This is our much larger data frame, and here we have the .txt, the metadata, and the CSV with annotation. Then of course there's a README annotation on there. That's all documentation. I typically just do the with ANN CSV. Hit enter to follow it up. Now I know whenever I download this, it's going to have an extra row, and I'll go ahead and share this to you real quick so that we can just get this out of the way. This is an error, and this is part of our cleaning. We'll get to this later. We're just going to ignore this error for right now. Let me just scroll down a little bit. So here's what we have. If we just read the CSV file as is, we get this column here that looks like it's supposed to be the header row, and it can be used as your header row. The only thing I really don't care for is that this is the column name, and as you can see, it goes on for a while, and I've seen this before. I mean, there can be up to, I think, like 50 or 60 words in just one of these, whereas you could just have this as your header column, these nice, neat little classifications up here. And that's what we're going to do. So let me go back, and I'm going to get rid of that. And to fix this, we are going to read this in as same file name, but we're going to do a skip rows. And then to format this correctly, you want to do a bracket. So skip rows equals bracket, and I believe it's 1 is what we're going to end up doing. Let me just double check this. And yes, okay, good. So there we have the column headers that we wanted. I'm going to go ahead and just do T2 equals pd.read CSV, and we are going to do our gross rent one now, comma, and it's going to be set up the same way. So we're just going to do the exact same thing. So now, I mistyped. That explains some things. Okay, skip rows. There we go. Okay, so let me just print off the first 3 rows of each data frame so we can just have a real quick look at it. Excuse me. There we go. So here we can see these two look very much the same, or at least very much similar. We have this GeoID column here in both. GeoID 2, same thing. Display label, same thing. And then this is where our columns start to get a little bit different. HC01 versus HD01. And we will get into changing the names of these headers in the next video, but for now I actually want to merge these two tables together, so that whenever I make my changes, I don't have to keep running back and doing one change to one data frame and then make sure I do the same change to the other one, or that a change will even work. So what we want to do for that is do what's known as the merge function. But before we do this, I do want to show you something else. So first things first, the easiest way, whenever you're going to do a merge, you want to know at the end of it if it worked properly. And of course, we're going to have a whole lot of columns, we're going to have a lot of rows. So the easiest way I've found to do this is to print off, Pandas has a shape function in the data frame variables. And all this is just simply showing you how many rows and columns are in each data frame that you have. And I'm using a print function here, otherwise it wouldn't, I would have to do these in 2 separate cells. But we're going to print the T1 shape, and then we're going to print the T2 shape. So, as you can see, there are 5,162 rows in both of our data frames. But T1 has 551 columns, and T2 has 17 columns. What does this mean? All this actually means is that whenever I merge these together, what I should expect to see is a 5,162 row spreadsheet with 567 columns, because we're going to merge these on a single column. So it wouldn't be 551 plus 17, it would actually be 550 plus 16, or 550. Wait, anyway, sorry. So I'm not going to save these as a variable at first here. Let me just do the merge real quick. And let's see here. It's, yes, pd.merge. As you can see, there's some other merges there. I haven't really dealt with those yet. But anytime you want to do a merge, you're basically calling up pandas, your library, the function merge, and we're going to call them with an open parenthesis. The first argument will be T1, that variable, separated by a comma, T2, and then a comma. And the next thing we're going to do is we're going to tell pandas how we want to merge these together. And let's do on equals geo.id. Okay. So a couple of things happened here. One, we had a GeoID, that is our main column that we merged on together. The second column here, GeoID underscore X, is like that because, and I think we'll be able to see it over here. No. Because there was another column that had the same name, it basically said, okay, I got to put both of these columns and both of the data frames into one single data frame, so I have to rename them. So I'm going to take GeoID2 and geo.displayLabel, and I'm going to put them all together into one. I'm going to rename them X and Y. So let's rename these two columns that were the same in both data frames as now X and Y of each other. That's really inconsequential. We don't care. because we're going to end up just dropping a couple of those columns anyway. But we've now merged it together onto one single data frame. And how are we going to test that it worked? Scroll all the way down to the bottom, and we have 5,162 rows, 567 columns, which we'll actually have to get rid of a couple now that I think about it, since we have an X and a Y. So we should actually end up here with 565 columns once we drop those rows, which I will get into in the next video, as we're going to get more into cleaning the data frame after this one. But now you should know how to load in your data frame, and if you have a CSV that has extra rows that you don't care about, you can do a skip row on them. You can look at the shape of the data frame to see how large it is, and then you can merge and confirm that the merge worked by comparing the size of your result with the size of the two data frames. And that's, in a nutshell, how merge functions work. So in the next video, we'll go on to cleaning the data. If you have any questions, or if something just doesn't work for you, please let me know in the comments. And I will try and get another video up this weekend here.